Okay, now just let me know whether am I okay. Am I, I'm not audible. Okay, so let's whoever not able to hear me, just you can type. Okay, you can write. Okay, now am I audible? Okay, I hope now everything is fine. So if you have any doubt or any problem, just let me know. Okay, in between. I hope like it is audible to everyone. Okay, Jane VRR, you didn't switch on your that microphone. That is why I think you are unable to hear me. Okay. Okay, so let's start. So this is our second lecture for this chemical kinetics. Okay, so before that one, let me introduce myself, Lachnak. Like yesterday also I have taken the class. Okay, so this is our second lecture for this chemical kinetics, and we have already seen some concept of this chapter. Okay, like we can say we have seen all these things. Okay, these are the things yesterday we have discussed. Okay, like for any reaction, suppose then reaction is taking place, how to find out rate of disappearance of reactant or appearance of product, or we can say speed of any reaction, how to find out. We have discussed this formula like average rate of the reaction or instantaneous rate of the reaction. Average means overall what is the change by changing the time, and instant means at particular time. Okay, or in instant what is the change, and we have seen how to find out this value by using the graph. Okay, we have already seen this. So this one is for reactant, then this one is a product. Okay, and by rate law, not rate law. Okay, but we can write rate of any reaction in the term of reactant and the stoichiometric coefficient. For example, suppose we have this one A is converted into BV. Okay, so how we can write rate of this reaction? Rate of this reaction is equal to 1 by A. Okay, 1 by, okay, let me change this ball pen. Okay, change of A with time equal to 1 by B, change of B, okay, with respect to time. So these are the things we have already seen. Okay, so rate of the reaction with respect to this is reactant and with respect to product. Okay, and we have also seen different type of reaction, slow reaction, fast reaction. Okay, we have already seen them. Okay, so and we have also taken some example. Okay, so today we are going to continue with this one. Okay. Okay, sorry. Okay, so let's these are the recap. Like yesterday we have discussed all the things. So today we are going to discuss these things. Okay, rate law, unit of rate constant, elementary and complex reaction, molecularity of reaction. So don't worry, we'll discuss one by one. Okay, rate law is nothing but write the rate of equation, rate of the reaction in the term of reactant. Okay, and we will have one proportionality constant we'll get in rate law, and we're going to find out the what is the unit of that one. Okay, unit means like what is the unit of time, that is second. What is the unit of distance, that is meter. Like that we'll see all these things. Okay, now. And after that, we will see the elementary reaction and complex reaction. And we are going to discuss which is called elementary reaction, which is called complex reaction. And after that, we will discuss what is the molecularity of the reaction. Okay, so one by one, we will see them. Okay, so I hope you, everyone, you got the idea like what today we are going to do. Okay, now, so we'll going to discuss this 4 concepts today in today's class. Okay, so okay, I'm again telling you, if you have any doubt in between, just let me know. Okay, I can repeat that one. Okay, but if this chapter is a simple chapter, okay, simple concept, you can easily understand it. Even though if you have any doubt, just let me know. Okay, so let's continue. Okay, so let's continue. So what is rate law? So last class we have seen like how to write rate of any reaction in the term of reactant and product with their coefficient. We have seen that thing. Okay, so today we are going to discuss or write rate of the reaction. Rate of the reaction, for example, we have this one, AA is converted into BV or other also. So how to write this reaction, rate of this reaction in the term of only reactant. Okay, and that is called rate law. Okay, so let's define what is rate law. Okay, so let's define this one. So for example, okay, so this rate law states that rate of any reaction is directly proportional to concentration to the power some value. Okay, or we can say it has some power. Okay, so what do you mean by this one? For example, we have this equation in which we have taken A mole of A, B mole of B, which give us C mole of C and D mole of D. Okay, so how to write rate law for this one? So according to this definition, we come to know rate of this one is directly proportional to some power of its concentration, some power of its reactant, concentration of reactant, or reactant is A and B. So we have taken some power. Let's say those are X and Y, X and Y. Okay. After that, to remove the proportionality constant, sorry, to remove the proportionality, we use some constant. Okay, we use some constant that is K. For example, that is K. And this K is called rate constant. Okay, name of this rate constant. For example, in physics, we have studied the force is directly proportional to mass. Okay, so if we remove this one, so what we can write? Force equal to mass into acceleration. So this is our constant. So like that here also, rate or speed is directly proportional to some power of reactants, constants of reactants. So we place some constant, and this is name of this constant is called rate constant. Okay, rate constant, and this rate constant depend upon the type of reaction. Okay, so like if you varying the type of reaction, or for we can say for different type of reaction, we have different value of rate constant. Okay, and these also depend upon the temperature. That means what? For any particular temperature also, if you varying the temperature, if you changing the temperature, it will affect the concentration. Because of that, rate constant will change. So we can say this rate constant is the function of two things. One is type of reaction, another one is temperature. Okay, and now we are also going to discuss about different type of reaction based on their order. Don't worry, we will discuss this order. What is order? Okay, like in mathematics we have studied na. So what is the degree of this equation? For example, we are given this one. Just suppose you are given y equal to x cube 2x plus 9. So what is the order of this reaction? Sorry, this equation. Okay, what is the degree of this one and what is the order? So like that. Okay, so this is in mathematics. So in chemistry also we have that type of term. Okay, the same thing only. So let's discuss this. What is the order? Okay, so before that one, so now from rate law we can relate speed or rate of any reaction with the concentration of reactant, and they have some power. And here we got one constant that is called rate constant, and that is dependent upon the reaction and temperature. We have discussed. So everyone understood this till now, or do you have any doubt here? Just let me know if you have any doubt. Okay, so let's proceed. I hope you don't have any issue, and if you have any doubt, just let me know in between also. We can discuss this. After that, so now let's discuss what is order of any reaction. Okay, like perhaps you've heard, if you go on through this chapter, first order, zero order, okay, second order, third order. So what is that order of any reaction? Okay, so let's discuss this one. So let's take, we have equation, this one, A plus B give us C mole of C and D mole of D. And if you're using the rate law, then we can write the rate equal to K, A to the power X and B to the power Y. Okay. So this, what is X? Suppose you ask what is X and what is Y? This is a power, we can say power. So we can say this is the order of, this X is the order of A, or we can say order of this reaction with respect to A is X and with respect to B is Y. Or for example, we have taking some value of X and Y, then we can write, let's say I'm taking rate equal to R. So K equal to, for example, we are taking A to the power 2 and suppose B to the power half. Then we can say order of this reaction order of this reaction with respect to A is 2. That means if you varying the value of A, whatever the change you will get new rate, that is twice of that one. Okay, we can say or for according to B, or like order of this reaction with respect to B, that is half. Okay, and now if we ask what is the overall order of this reaction, that is with respect to respective reactant, with respect to A, with respect to B, then what is the order of this reaction? In that case, what we will do, we add them. We add the power of A and power of B, and whatever the value we will get, that is the order of overall reaction. Okay, that is X plus Y. So now if we ask what is the order of this reaction, order of this reaction, whole reaction, so we can tell order of this reaction is 2 plus half, that is equal to 2.5. So we can say 2.5 is the order of this reaction. Simple. Okay, so simple. Okay, so everyone understood this. So how to find out order of this reaction, everyone, or do you have any doubt? If you have any doubt, just let me know, otherwise we can proceed. Okay, so let's proceed now. So now let's see whether we can find out, suppose we are given any reaction. Okay, so can we find out order of that reaction? For example, you are given this reaction 2NO react with oxygen and give us 2 mole of NO2. Okay, in that case, what is the order of this reaction? Can we find out? Okay, so just remember this order you cannot find out by merely seeing that any reaction. Okay, because this order is a experimental value. Like suppose you are taking this reaction only. So to find out order of this reaction, order will give you an idea about what is the impact of this reactant on the rate, speed of the reaction. I mean, if you vary the value concentration of NO or O2, how that will affect the reaction or speed of the reaction. That is what the order will tell you. Okay, and this order you cannot merely find out this one by looking at the equation. These are the experimental value. Okay, and how to find out that one? Based on this, we will solve one problem. Okay, so to find out order of any reaction, what we are doing, we are changing value of NO and O2, and we get some value. Okay, and using those value, we can find out order of the reaction. Okay, so don't worry. Based on this, we will solve one question so that we can have clear idea how to find out order of the reaction. Okay, order of the reaction. So now we come to know this order. You cannot like find out easily. Okay, those are because those are experimental value. Okay, experimental value. So everyone understood this till now, or do you have any doubt? Just let me know. If you understood this, so let's solve one problem based on the simple problem. Okay, and everyone please, so the question is this one. So everyone try to solve this, and possibly you can write that answer in this chart. Okay, or else we can discuss this one. So but please everyone try to solve this, at least try to write the data. Okay, so that while I am solving that one, you come to know like how to use this data to solve this type of problem. Okay, the attempt is important, even though you not get the correct answer in first attempt. Okay, because it's a new concept. Don't worry, but at least you try this your own. Okay, the question is the conversion of molecule X to Y follows second order kinetics. If concentration of X is increased to 3 times, how will it affect rate of formation of Y? Okay, I mean, if you also initially we have some concentration of X, after that what we did, we change its concentration to 3 times, we change it to thrice. So what is the effect of this change in concentration to the formation of Y? Okay, try to solve this. Like you can use the rate law for this one. Okay, so everyone you try this. Okay, so let's solve this one. So according to rate law, we are given X is converted into Y. Okay, so X is converted into Y. So if we are using this rate law, then we can write rate, I denote this with R, equal to rate constant K in some power of X, And what is the power of X? Because in the question we are given, this is second order kinetics. That means what? The order is 2. So we can write rate equal to k x to the power 2. Okay. So after that, according to the question, we change the concentration of x into 3x. Okay, so let me change the color. 3x. So we can say, so let's the new rate is r prime. So, and I told you, if you don't change the type of reaction or the temperature, then k remains same, rate constant remains same. And now this x become 3x. Okay, and we take square of this one. So if we solve this one, we'll get k multiply. Okay, let's don't take the. Okay, otherwise there is some confusion. So we can tell this is 9x square. We need the relation between r and r prime. So what we do, we divide them so that the same term will cancel out and we will get the relation between r and r prime. So let's just equation 1 and this is equation 2. So divide them. If we divide, then we will get r divided by r prime equal to like here we have x squared by k. This is 9 and this is x square. Okay, so the same term they will cancel out. Okay, and you will get 1 by 9. So if we rearrange this one, then you will get 9r equal to r prime. That means whatever the new concentration or rate of the reaction will get, that is 9 times the initial rate constant. Like not rate constant, but the rate of the reaction. Like whatever the initial speed, the new speed is 9 times of that one. Okay, so this is the relation between initial and final. So everyone understood this. What is the speed of this second reaction? Everyone? Or do you have any doubt? So do you have any doubt or is like we good to go? Okay, so let's proceed for the second one. Take. Okay. So I told you like to find out rate of any reaction, sorry, order of any reaction, we need some experimental value. Okay, so experimental value. So how to find out this one? Suppose we are given some value, experimental value of A and B. Okay, so let me read the question for you. In a reaction between A and B, the initial rate of reaction R0 was measured for different initial concentration of A and B is given below. Okay, and this is the data, like this is the table. Okay, and here we have to find out what is the order of the reaction with respect to A and B. So like we can see in first column, we are taking the concentration of A is 0.2, B is 0.3. And at that time, the rate of the reaction is 5.07 into 10 to the minus 5. Okay, similarly in second column and third column, we have some data. Now we have to use this data to find out order of the reaction with respect to A and B. Okay, so everyone please try once. After that, we will discuss. At least you try that one, like try to write the data. Okay, let's take a hit trial method, like whether we can try to solve this or not, able to see solve this or not. After that, like we will discuss. Okay, so everyone, you solve this. Like you can use this rate law to find out order of the reaction with respect to A and B, because we need order with respect to A and B now, so you need to find out X and Y. Okay, so for that you need to write the rate law. Okay, rate law equation for this particular reaction. Okay, so let's discuss this one. So this reaction, it consists of two reactant A and B, and which react to give us product. Because while we're writing the rate law or try to find out the order of the reaction, we don't need the product. That is why there is no use of this product. Only we need the reactant. Okay. So let's, according to this rate law, let's assume the rate of this reaction is like this. Like we can write like this. Okay, and we need to find out value of X and Y. After that, put this value of A, B, and R0 here. Okay, and then if we put this first value, that below first column, then we can have this. This value, while you taking rate is this one. So just put the value of A and B here, we'll get this equation. And if we take the second one, then we'll get the second equation. Okay. Now we need to find out the value of X and Y. So what we are doing? If you see this equation carefully, then you will find here this value is similar to this one, which are unknown. Okay, so if we divide equation 1 with equation 2, so in that case, what will happen? These two value will cancel out, and we will left with this only y term. Okay, so to get the value of y, let's divide these two. So if we divide these two, then we will get this one. Okay, so if we divide these two, we'll get this one, because this is the same term, so they will cancel out. Okay, and this also cancel out. So finally, we will get 1 equal to 3 to the power y, 3 to the power y, and we know this, anything to the power 0 equal to 1. That means because we get 1 here, so y have to be 0. Okay, so that if you put 0 here, then you will get 1. That means what? From here we can tell the value of y equal to 0. Okay, y equal to 0. So from here we get y equal to 0. Okay, so y equal to 0. Everyone understood this? How we get the value of y? Would be in a doubt? Just let me know. Simple, what we did, we write the rate law. In rate law, we put the value, the given data. Okay, and like when we see this one, we find these two are same. So if we divide them, they will cancel out, and we have a relation between y. Okay, so we can easily find out the y. So I use this one, and from here I get the value of y equal to 0. Okay, now let's find out the value of x. Okay, so to find out the value of x, let's take this first column and the last one. Okay, so if we take the first one, so let's take this one. So I take the first equation only, but I replace the value of y with 0, because we got the value of y equal to 0. So I put here 0. Okay, these are same equation. These two are same equation. I just put the value of y. After that, I take this column, this one. Okay, I take this one, and we know this, the value of y equal to 0, and put x is as it is only. Okay, after that, so because something to the 0 equal to 1, so this becomes 1 and this become 1. Now divide equation 3 by 4, and you will get this divided by this. So we approximate this 5.07 into 1. Okay, and this one we can write like 0.5 into 10 to the power minus 4. Okay, so if we divide this one 0.5 into 10 to the minus 4 divided by 1.43 into 10 to the minus 3, then you will get 0.5 by 1.43. Okay, so if you bring that, so like if you remove this one, then you will have 14.3. So if you solve this one, then you will get the value of x equal to 3 by 2. X equal to 3 by 2. Just solve this one, then you will get value of x equal to 3 by 2. So everyone understood this, how we got the value of x and y. Okay, now we can tell, because we got the value of x and y, so we can tell keep order of the reaction with respect to a is 3 by 2. 3 by 2. That means if we write this one, so k equal to a to the power x. X is how much? This is 3 by 2. Okay, na? And y equal to 0. So y equal to 0, so we can write 0. So from here we can tell the order of the reaction with respect to a is 3 by 2, and with respect to b, that is 0. So everyone understood this, how we got this value, like how to solve the value of x and y, and writing the order of the reaction with respect to each reactant. Now tell me, what is the order of this whole reaction? How much we will get order of this reaction if we know the respective order of each reactant? Okay, so correct. This is, we will get 3 by 2 plus 0, that is 3 by 2 only. So the order of this reaction is 3 by 2. 3 by 2, because we just add the power of A and B to get the order of overall reaction. Everyone, you understood this concept, or do you have any doubt? Just let me know, so that we can discuss. Okay, so I hope you don't have any doubt here. So let's proceed for the next. Okay, so now let's find out what is the unit of rate constant. Like by using rate law, we can relate the speed or rate of the reaction with the concentration of reactant. Okay, and there we got one constant K, that is rate constant. Now let's find out what is the unit of that rate constant. So usually, for example, we have this one. Okay, like force equal to mass into acceleration. And if they ask you what is the unit of A, acceleration, so how we are finding? We take A equal to F by M. Now we put, because it's equal to sign, so whatever the unit of F by M, that is equal to A. And we know the unit of force and this mass, so we can easily find out the unit of A. So similar logic we will use here also. Okay, so let's find out what is the unit of this rate constant. Okay, rate constant. So let's assume we have this reaction, like common reaction we are using. A mole of A react with B mole of B, which give us C mole of C and D mole of D. Okay, so for this one we can write the rate law equal to this. Rate equal to K, A to the power X, B to the power Y. Okay, and because we need to find out the unit of K, so let's separate them so that whatever the unit of this value, rate divided by this term, that is same for K, because this is equal, no? Both are same. Okay, and we know this unit of this rate and this one. Okay, so here this one are like A to the power X, B to the power Y. We can, like in aggregate, we can write concentration of reactant to the power its order, and order is X plus Y, and we can replace this X plus Y with N, because we know na order of the reaction is N. Okay, so we can write this one. Okay, so now let's find out what is the unit of K. So rate of reaction means change in concentration with respect to time. The unit of concentration is mole per liter. This is mole per liter, molarity. Okay, and time is second. So we can write rate of the reaction unit is mole per liter per second. Okay, and denominator concentration to the power X plus Y, that is N, and unit of concentration is mole per liter to the power N. Everyone understood this? So if we rearrange this one, then we can write mole per liter per second, ठीक ना, divided by mole per liter to the power N, Okay, so now here you can see both in numerator and denominator we have mole per liter. So what we are doing, like we know this one, suppose you are given A to the power X and A to the power Y, so we can easily write A to the power X minus Y. So similar logic we will use here. So power of this one, mole per liter is 1. Okay, and this power of this one is N, so we can minus 1 minus N. So 1 minus N, and this one is per second is this one. So we can tell for any reaction, unit of rate constant is mole per liter to the power 1 by N per second. This is the unit. Okay, just everyone write this one. Okay, based on this, we'll solve one numerical based on the simple one. Okay, everyone write this first. Everyone done? Or you can take the screenshot. Okay, so I hope you understood this, like how we solve this one, like how we got the unit of K. Okay. So, okay, so everyone, that means what? Everyone, you taken that note of that one. Okay, so now let's find out what is the unit of K or rate constant for different reaction, like for zero order, first order, second order, and third order. Okay, so let's take one by one. So if you varying the value of N, then you will get different type of order of the reaction. Like if you put N equal to 0, that is zero order, N equal to 1, first order, N equal to 2, that is second order, like that. So for zero order, just put N equal to 0, then you will get the unit is mole per liter. N equal to 0, so this becomes 0, so you will get mole per liter per second for zero order. After that, to find out the unit of K for first order, just put the value of N equal to 1. So you will get N minus 1 equal to, 1 minus 1 equal to 0. So mole per liter to the per 0. So this whole term become 1. So for first order reaction, the unit is per second, 1 by second. Okay. And for the second order, just put the value of n equal to 2. Okay, n equal to 2, then you will get this one. Okay, so let me do this one. So if you take n equal to 2, then you will get mole per liter equal to -1 per second. So we can write per mole liter per second. So everyone understood now this one? Liter per mole per second. Or if we rearrange this one, you will get liter per mole per second. Okay, I hope you understood this one. Okay, so everyone understood now how we can find out the order of any reaction, unit of the K for different type of reaction, like zero order, first order, second order. You can try for the third and fourth also. Okay, third and fourth also. Just put the value of n equal to 3 or 4, then you will get the respective unit of K. Take. Everyone understood now this one? Okay, so let's see some question based on this. Solve some question based on this. Okay, so be ready and try to solve this. No? So now everyone try to find out what is the order of this reaction. So first one is like unit of K is given to us is like this, and this one is this. So try to tell me what is the order of this one, this one. Everyone try this, and you can answer me in the chat. Everyone try this. Okay, for that one you can use the general formula like mole per liter to the power 1 minus n per second, and relate that one with this, so that you can get the value of n, and that is the order of the reaction. Okay, so everyone you tried, na? Okay, so now let me solve this. Okay, so the simple thing, because we need to find out the order of the reaction, so let's write the general formula. Okay, general formula, so that we can get the value of n. So general formula is K equal to mole per liter to the power 1 minus n, okay, per second. So let's try to rearrange this with respect to this one. So this can be written K equal to mole per liter to the power half per second. So that if you take this half within the bracket, then you will get mole to the power half and L to the power minus half, okay, per second. So if we like compare these two equations, this one and this one, then we'll get 1 minus n equal to half. So if we solve this one, so n equal to 1 minus 1 by 2, so this is equal to half. Okay, so we can say this particular K is for half order reaction. Everyone understood how we did this? Simple, just write them such a way that you can relate the unit, okay, to get the value of n. Similarly for this one, okay, so similarly you have to write this one also, like rearrange such a way that you will get this term. So this can be written mole per mole liter to the power half equal to per second. Okay, so that if you take the half within the bracket, then you will get mole to the power minus half, L to the power minus half. Okay, so what I think you know this identity key. For example, this one, A can be written. A to the power minus 1 can be written 1 by A. Okay, 1 by A. So suppose you put anything to the power minus 1, then it will flip. Okay, so here also we can write like this: mole per liter minus half. equal to half minus 1. So why I put -1 here? So that I can get this mole per liter, so that I can easily compare with this one. That is why I rearrange them. Okay, after that, take this -1 with this, so we'll get overall mole per liter to the power minus half equal to per second. Okay, per second. So if we relate this now, this one with this, then we'll get 1 minus n equal to minus half. ठीक ना? So n equal to 1 plus 1/2. You will get 3/2. Everyone understood now how you get 3/2? Or do you have any doubt, anyone? Okay. Like you have to, whatever the given to you, you have to arrange this such a that you will get this term mole per liter power something per second, so that you can relate this one with the standard equation. Okay. So everyone done? Everyone understood how we get the order of this first equation? This is half, and for the second one, this is 3/2. So do you have any doubt, or we can proceed? Just let me know. Just see this can carefully, or you can take the screenshot. Okay. Okay, so let's proceed for the next concept. Okay. So that is now, let's find out, let's see what is elementary reaction and what is complex reaction. This is simple. Okay. Elementary means it consists of only one thing, and complex means like combination of more than one. Okay. That is a complex. This is simple idea. So let's define one by one, like what is elementary reaction, what is complex reaction. Okay. So if we're taking this example in which hydrogen is aired with oxygen and give us water. So this is one step. One step means simultaneously hydrogen, oxygen, they combine to give us water. Because this reaction is taking places at single step, that is why this reaction is called elementary reaction. Elementary reaction. So in elementary reaction, only one step. Okay, like they combine to give us product. But there are some reaction which proceed in different steps, 2 or 3 steps. So we let's see those also. Okay. So what is elementary reaction? The reaction which is taking place in the single step, that is called elementary reaction. Okay, elementary reaction. And what? Okay, so if we want to find out order of this elementary reaction, then we can say sum of stoichiometric coefficient of the reaction. That means what? If we want to find out what is the order of the reaction, for this one, that is 3. Okay, because this is an elementary reaction. But for complex reaction, that is different. For complex reaction, that is different. Okay. So just remember, for elementary reaction, if you want to find out the order of the reaction, that is equal to sum of the stoichiometric coefficient. So stoichiometric coefficient means this value. Here we have 1. So 2 plus 1, that is 3. Okay. And now let's see the complex reaction. Before that one, so carefully see this one. Here we have 4 mole of HBr react with oxygen and give us 2 mole of water and 2 mole of Br2. Okay, so we think this may be proceeding with a single step, but that is not like that way. Okay, it proceeding, or we can say to get the product, that is water and Br2, it needs different step or different step. So let's see this one. First, this H1 mole of HBr react with oxygen, and first it will give you this product. After that, this compound react with HBr, and this will give you this. In third step, again 2 mole of HBr react with HOBr to give us final product. Because this step consists of total 3 steps, that is why this is called complex reaction, and each step is a elementary reaction. And these, or we can say, if any reaction which consists of more than one elementary reaction, that is called complex reaction. Okay, complex reaction. This is our complex reaction, and I told you each step is elementary reaction. And among these, there is one elementary step, which is slowest one. That will determine the rate of the reaction, like which type of product it will give you. Okay, and order of the reaction also. So overall rate of the complex reaction is determine the slowest step. Okay, so among these 3, now there is one step which is slowest. Okay, like proceeding slowly, that will give us the order of the reaction. that elementary step will give you the overall rate of the reaction. Okay, or order also it will give you. Everyone understood this, like the difference between elementary reaction and complex reaction? Everyone, or do you have any doubt? Anybody? Okay. So let's proceed with this concept. Okay. Now let's discuss the molecularity. Okay, molecularity. For example, if we want to manufacture ammonia, so we are taking like this N2 react with H2, okay, and it will give us NH3. And if we balance this one, so we can write 2 nitrogen, so put 2 here, now 6 hydrogen, so put 3 here. Okay, so here we are taking some amount of nitrogen, or here 1 mole of N2 and 3 mole of H2, and it will give us NH3. Just remember, whatever the amount of nitrogen and hydrogen you are taking, all the atom or the molecule will not give you the product. There are some molecule only give you the product, and those number of particles which give you the product, those number is called molecularity. Molecularity. So what is molecularity? Molecularity is the number of the reactant molecule, atom or ion taking part in elementary reaction which collide simultaneously, okay, to form the product. So even though you are taking like large amount of particle, only some particle they collide perfectly. Or now we can come to know if there is collision between the atom or the ion, they will give the product. Which are collide perfectly and give the product, those number of atom is called molecularity of that reaction. Molecularity of this reaction. So for example, in this reaction, we have taken X mole of A and Y mole of B, which give us C. So molecularity in this case is because we are taking X mole of A and Y mole of B. So total we have taking X plus Y number of molecule. So this is the molecularity of this reaction. Molecularity of this reaction. Okay, everyone understood this? What is the molecularity? Or we can say active particle which give us the product. Those are called molecularity. So here in this, when PCl3 is give us PCl5 give us PCl3 and Cl2. Because we have taken only one molecule, so molecularity of this one is 1. And this type of reaction is called unimolecular reaction. Unimolecular reaction in which only one molecule taking part. Okay. After that, if you are increasing the number of particles which gives you the product, okay, which give you the product. And for example, this first one, if you take first one, here we are taking 2 mole Cl2 and CH4. They combine to give you HCl and Ca3Cl. Because here we are taking 2 molecule. That is why this is called bimolecular reaction. Okay. And similarly, if you are taking more than that, it will increase into trimolecular. Okay. So first one, this one is second, and this one is trimolecular. Okay. So now tell me. So everyone understood, na, like how to find out the molecularity. Simple. The number of particles there give us the product. Those number is called molecularity. So here we are taking 2 molecules, so the molecularity is 2. And here we are taking 3, so molecularity is 3. So trimolecular. Okay. So now tell me, here we are taking 4 molecules A, B, C, D, and they give us the product. So what do you think? What is the molecularity in this case? Molecularity in this. So most of you are thinking in this case also molecularity become 4. Okay, but this is not the case. Okay, like maximum molecularity we can think of is 3. More than 3 is not possible. Not possible. Why not possible? So let's see this one. I told you when molecule they collide, they will give you the product. They will give the product. Okay. So the perfect collision is important. Perfectly collision, head-on collision. If they touch like this, it will not give the product. They has to collide like this only. Okay. So when 4 molecules try to collide, there is only one possibility. Like 3 can do the collision perfectly, but 4th one it cannot do that perfect collision. So it will move away because only 3 are enough to give the product. So we can say molecularity of 3 also rare will get, because 2 they can do the perfect collision, but if you increasing their number, there may not be that much effective. Okay, so that is why 3 is rare. That means 4 is not possible, or 5 more than that one. Okay. Everyone understood, na? Why molecularity of 3 is rare? Because if you're taking large number particle, the collision is not perfect or effective, we can say. If the collision is effective, you will not get any product. Everyone understood, na? Or do you have any doubt? Just let me know. यहाँ तक किसी को डाउट है? और we are good to go. ठीक है, चलो हम आगे बढ़ते हैं. Let's proceed. ठीक. Okay, so now let's discuss which are the things we have seen in this class. So we have studied the rate law, and rate law gives us the relation between rate of the reaction with the reactant with some power, and there also we get this is constant, that is called rate constant. We come to know it is function of reaction and the temperature. I mean, if you vary the temperature, K will vary. Okay, and X and Y are the order with respect to A and B. And what is the overall order of this reaction? Just reaction. What is complex reaction? The reaction taking place. Just wait. I didn't switch on. I forgot to switch on this. Okay. So the what is complex reaction? Complex reaction is so it's taking place more than one step. No, that is complex reaction. And we also discussing the for complex reaction how to determine which is the rate determinant step, like which is give you the rate of the reaction. That is the slowest step among different for any complex reaction. It consists of different elementary reaction. So among these elementary reaction, one is slowest. This will give you the speed or the rate of the reaction. Okay. If you are studying this organic first chapter, like perhaps you have studied this, which is called the rate determining step, how to identify that one, like that. Okay. After that, we seen the molecularity. Molecular means the number of actual particles which are participating in the reaction to give you the product. That is called molecularity. In molecularity of 3 is rare. That means more than that is not possible. Okay. So these are the things we discuss in this section. Okay. Everyone understood, or do you have any doubt from here? Just let me know. We have 5 minutes, we can discuss. Okay. Or okay, so next class, if I'm taking, or if Gopi sir is taking, so whoever taking, he will continue the integrated rate law. This is simple one. Integrated law is simple one. Okay, like because now we are studying now, we change concentration of any reactant with time. And this integrated law will tell you at particular interval of at particular time what is the concentration of that reactant or product. So integrated law. So here we will study the integration. So before coming to this next class, please go through the concept, some simple concept of integration, so that you will not get confused. Okay, so just study the integration of 1 by x. Okay, 1 by x or x to the power n. If you understand this one, integration of these two, the next class you can easily understand it. Integration of 1 by x and integration of x to the power n. If you do, like, if you understand these two, then this integrated law is nothing. Okay, you can easily solve this. So I hope everyone understood this, like whatever I teach. Okay, and please try to solve question based on this chapter. Okay, like theory is not important. Like if you go through the book, you're studying the book, and if anyone teaching you, like you feel like you understand everything. Okay, but if you're solving problem, you stuck somewhere. Okay, so please try to solve a good amount of question, a good number of question, so that whatever the concept you're studying, you can by heart easily. Okay, na? So I hope everyone understood this. So if you don't have any doubt, you can give me the thumbs up and you can leave the class. Okay. Okay, then everyone. Bye. Okay, so I'm ending the class. Okay. Thank you, everyone.